guys. This is where we stopped yesterday. We stopped at the problem before this one. So this is where we're picking up today with dividing. Because we did some with multiplication yesterday and did a few division. Today we're going to do division and complex fractions. Now, here, the x plus 3 squared denominator is understood to be 1. Now, before we factor or do anything else, we do need to change it from division to multiplication. Because we keep the first one the same. We change it from division to multiplication and flip the second term. Now, the second term, we can leave it as x plus 3 squared, or we can say that it's x plus 3 times x plus 3. So we could have left it as x plus 3 squared, or we can say x plus 3 times x plus 3. Either one's going to be the exact same thing. Now we do need to factor the rest. X squared and 1 are as simplified as they get. If it's a single term, there's nothing we can do to it. So the only one that we can factor is x squared plus 8x plus 15. Since the x squared doesn't have a number in front of it, it's understood to be 1. It's understood to be 1, so there's no greatest common factor there with numbers. And since the 15 doesn't have a variable, we know we can't factor it out. So there is no greatest common factor between x squared, 8x, and 15. Now, what we're hoping is one of the factors for this is going to be what? X plus 3. Because if one of them is x plus 3, it'll simplify. Now we look at this here. Since the third term is positive, the signs are the same and match the sign of the middle term, plus and plus. Factors of x squared are x and x, and the factors of 15 that we want are 3 and 5. Questions on this so far? Now we can multiply these together as one fraction, which would put us with x plus 3 times x plus 5 times 1, which really doesn't add anything to it. The denominator, we're going to multiply x squared by our x plus 3 times x plus 3. And we did notice they do have something in common. An x plus 3 and x plus 3, which will leave us with x plus 5 over x squared times x plus 3. And that's as simplified as it gets. Bless you. Any questions on this here? Really, the only difference between division and multiplication is our first step of keep, change, flip. From then on, it's just multiplication. Yeah. You're good? We're ready for the next one, yes? Keep, change, flip. So we'll keep the first one the same. So 12x squared minus 22x plus 8 over 3x. Change it from division to multiplication and flip the second. So now our 2x squared plus 4x is on top. And our 3x squared plus 2x minus 8 is on bottom. Keep, change, flip. Now, out of the 4 places we have our 2 numerators, 2 denominators, the 3x is as simplified as it gets. We only have one term, so there's nothing we can do with it there. Which one do we want to try factoring next? I would look at the 2x squared plus 4x. 2x squared and 4x, do they have a greatest common factor? They have 2 and they have x. So we can factor 2x out of both terms. If I factor 2x out of 2x squared, we're left with x plus 2x factored out of 4x. The x factors out completely, and 4 divided by 2 is 2. So now we need to pick between the 12x squared minus 22x plus 8 and 3x squared plus 2x minus 8. Which one do we want to factor next? X squared minus 22x plus 8. Is there a greatest common factor between these three terms? 2. Because we could see if there's a bigger number, but 2 does work. 2 factored out of 12x is 6x squared minus. If we factor 2 out of 22, we have 11x plus 2 factored out of 8 is 4. So we'll still need to factor it from there, but we can pull that 2 out. So it'll make it a little bit easier to factor. And that leaves us with the last one, 3x squared plus 2x minus 8. Is there a greatest common factor? No. So we can go on and do our parentheses. Since the third term is negative, our signs are opposite. One's going to be positive, one's going to be negative. Then we look at the factors of the first and third term. Factors of 3x squared have x and x, and we need to decide which one's going to have the 3. Well, at this point, we can just pick one because it's not really sure which one it would be. So we can pick one, and the factors of 8 are 1 and 8 or 2 and 4. Which one do we want to try? 2 and 4. As again, we can always check it to make sure this works out. 3x times negative 4 is negative 12x. 2 times x is plus 2x, which gives us a negative 10x. Not quite what we wanted. We can flip 2 and 4 and try it again. 3x times negative 2 is negative 6x. 4 times x is plus 4x is negative 2x. Is that what we wanted? No, but it is the right number. It's just the wrong sign. So we just need to flip the signs. And this would give us a positive 6x, negative 4x, which does make the 2x positive. Now we have one last thing to factor. Is our 6x squared minus 11x plus 4. Since our third term is positive, the signs are the same and match the sign of the middle term. So negative and negative. Then we need to find the factors of the first and third term. Well, 6x squared, we will have x and x. Then we'd have 1 and 6 or 2 and 3. Yes, we can do 2 and 3. Now we also need to look at the factors of 4, which is 1 and 4, or 2 and 2. Which one do we want to do? 1 and 4. We can't use 2 and 2 actually, because if we did 2 and 2, the first parenthesis would have a greatest common factor of 2, and we know that 6x squared minus 11x plus 4 does not. So that means neither one of these can have one. It also means that the 4 can't be with the 2 anyways. So we have that to look at. Also, if we look in the denominator, what is one of our parentheses in the bottom of the fraction? 3x minus 4, yes? So if we had 3x minus 4 on top, that would help us also. If we do check this, 2x times negative 4 is negative 8x. Negative 1 times 3x is negative 3x, which does indeed give us the middle term, negative 11x. So let's see what we have in common. Well, 3x minus 4 and 3x minus 4. We also have x plus 2 and x plus 2. Is there anything else in common? Because we do have x over x, yes? And that would simplify to just 3 on bottom. And the numerator, 2 times 2 is 4 times our 2x minus 1. Any other questions on these here? We'll look at one more of these here with dividing, and then we'll move on to our complex fractions. And with any of these here, before we start factoring, it's going to be good to do our keep, change, flip. Keep the first one the same. Change it from division to multiplication, and flip the second rational expression. Keep, change, flip. And after we do that, then we will factor. So we do keep, change, flip, and then we're going to factor. Now, which one I would factor first is kind of a close tie between the top of the numerator of the first rational expression and the denominator of the second. Because the numerator of the first, x squared 16, is their greatest common factor. No, but what do we know about x squared minus 16? It's a difference of perfect squares. So we're going to have plus and minus. Factors of x squared are x and x. And 16 is 4 and 4. So x squared minus 16 is x plus 4 times x minus 4. Now the denominator of the second one, does 3x minus 12 have a greatest common factor? 3. And if I factor 3 out of 3x, we're left with x minus 4. Now we need to determine which one we want to factor next. I'll pick the denominator of the first, our x squared minus 10x plus 25. There is not a greatest common factor. There's nothing we can factor out. So we'll do our 2 sets of parentheses with 3 spaces. Since the third term is positive, our signs are the same and match the sign of the middle term, which is negative. So we have negative and negative. Factors of x squared are x and x. Factors of 25 are 1 and 25, or 5 and 5. Which one do we want? And 5. And again, if we did our check like we've done before, this would give us negative 10x. That brings us to our last one. X squared minus 3x minus 10. Again, no greatest common factor. But since the 10 is negative, our signs are opposite. One's positive, one's negative. Factors are x and x. And factors of 10 that we want are 2 and 5. Which one's positive? 2. 5 would be negative. And at this point here, we would multiply together and simplify. So what would simplify? X minus 4 and x minus 4. X minus 5 and x minus 5. What else? That's it, yeah. Yeah, those are the only things that factor. Nothing else is in common on top and bottom. So the numerator is left with x plus 4 times x plus 2. The denominator is going to be 3 times x minus 5. Any questions on any of these here? No. We can pick any one. Now, I always pick the easy, or what I think is easier. When I say that, I mean the ones that I can see the factors first. So x squared minus 16 and 3x minus 12. Well, x squared minus 16, difference perfect squares, x plus 4, x minus 4. Yes, because then here, okay, x minus 4, those match. Once we did this one here, x plus or x minus 5, x minus 5. Okay, if I want something to simplify, this one here needs to have an x minus 5 or an x minus 4. Well, we know the x minus 4 didn't matter because that's already gone. Okay, then we're looking at factors of 10, 1 and 10, 2 and 5. Hey, the 5, if I want one to match, it'd be good to have it. They're both negative, so I'm going to need that 5 to be negative. So that's sometimes helpful, especially when we get to ones like this here, where, okay, this one was pretty nice to factor. Okay, well, if this has an x plus 2, the denominator hopefully will have 1. So we get that there. Okay, it had 3x minus 4. When I factor this one, it has 1. I can start using it as ways to help factor the others and eliminate some possibilities. Because it's one of those things that's not a hard rule, this is what you do every time, but it's more of how can I feel out what needs to be factored and how. Yes. Complex fractions. Now, we went over 2 methods to solve these. The first method we did once, which was adding and subtracting the numerator and denominator into a single fraction, changing it into division, and then going about it that way. The other method is to find the least common denominator, or really what do we need to multiply top and bottom by to get all of the fractions to cancel out. Well, in this one here, we have 2 fractions. We have 2 denominators inside the fraction. We have x squared and we have x. What would I need to multiply x by? Well, what is this denominator here? It's just an x. It has 1. This denominator has how many? So we need to multiply the entire equation by at least how many x's? 2. Because if I multiply the top one by x squared, the x squared and x squared would cancel, yes? If I multiply the bottom one by x squared, would the x simplify out with it? Because the bottom would be what? X squared over x, yes? So we'll start it here in a second, which would just be 1x, yes? So the least common denominator for this here would be just x squared. Because the numerator, the 1 over x squared, I need 2 x's. The denominator, the 1 over x, I need just 1. So the most that I would need to simplify this out is 2 of them. I need 2. And what we can do at this point here is multiply through. So we're going to multiply this x squared on top by both terms. X squared times 1 is x squared minus. When we multiply x squared by 1 over x squared, it multiplies with the numerator. So we get x squared over x squared. We'll simplify it here in the next step, but I want to write this out at least especially for the first time. We'll do the same thing with the denominator. X squared times 1 is x squared minus x squared times 1 over x is x squared over x. In the numerator, we'll still have the x squared minus x squared divided by x squared is 1. Anything divided by itself is 1. The denominator is x squared minus, well, x squared over x would be 1x. Because we subtract the exponents when we have like bases being divided, 2 minus 1 is 1. Bigger on top stays on top. So we get this here. Now this would be the end as long as the numerator and denominator don't factor and or don't have anything in common. However, x squared minus 1 is what? Difference of perfect squares, yes? Because factors of x squared are x and x. What times itself is 1? 1. So it gives us x plus 1 times x minus 1. Is there a greatest common factor, or can we factor the denominator? Well, they both have n. And if we factor x out of x squared, we're left with minus x factors out completely, so it is 1. Do we have something in common on top and bottom? X minus 1 and x minus 1, leaving us with x plus 1 over x. And this here is as simplified as it gets. The x in the denominator and the x in the numerator won't simplify out because of the plus 1. If we wanted to simplify this, we'd have to break it apart, saying x over x plus 1 over x. The x over x would simplify to 1 plus 1 over x. Is this here any simpler than that there? I'd say it's a little more complicated, or a little bit more complicated looking. So that would not be our final answer. X plus 1 over x is. This kind of stuff here is partial fraction decomposition. We're breaking it back apart. Questions on any of this here? Okay. Looking at this here, how many denominators in the rational expression do we have? Or how many fractions inside this rational expression do we have? We just have one, the one on top, yes? And what's its denominator? Hey, so what would I need to multiply it to get that denominator to go away? Hey, just A. But what I multiply to the numerator, I also have to multiply by the denominator. Because A over A is what? 1. So more or less, we're multiplying the entire fraction by 1. And if we distribute this, A times 25 over A is 25A over A, which will simplify to just 25 minus A times A is A squared. The denominator, A times 5 is 5A. A times A is plus A squared. Now we can simplify the numerator. The A over A simplifies, giving us 25 minus A squared over 5A plus A squared. Now the question is, will this factor? Is there a greatest common factor between 5A and A squared? A, and we can factor it out. If we factor an A out of 5A, we have 5, and A out of A squared is A. Now we could have written this as A plus 5 or 5 plus A. Those are the exact same things. Now will 25 minus A squared factor? Is it a difference of perfect squares? Because what times itself is 25? What times itself is A squared? Now we're used to having the A squared first. We're not used to it being second. But the process still works the same. We will have plus and minus. 5 times 5 gives us 25, yes? Will the 5 go first or second? 25 was first, so 5 goes first. So we have 5 and 5. A squared is A and A. And that's really it. Almost. Is what? 5 plus A will cancel, leaving us with 5 minus a over a. That's also part of the reason I didn't reorient 5 plus a in the denominator, because I knew it's going to match up with the numerator. But also 5 plus a and a plus 5 are the same thing. So it works in either way. Any questions on this here? Now looking at this one here, how many denominators do we have inside this fraction? 2. The top one has x plus 4. The bottom one has. So what would we need to multiply top and bottom by to get these to simplify? Do I need it more than once? How many times does it appear in each of the fractions in this fraction? So at the top, it only appears in each denominator how many times? In the bottom, it only appears, so I only need it. We would need it more than once if one of these was, say, squared, because that tells me the fraction in the bottom has it twice. So for it to simplify out completely, I would need it twice. But here, since it only appears in each one of these once, I only need to multiply top and bottom of it once. So the numerator, we're going to have 3 times x plus 4 over x plus 4 minus 2 times x plus 4, because we multiplied everything in the top of the fraction by x plus 4. We do the same thing in the bottom of the fraction. We'd have 5 times x plus 4 plus 2 times x plus 4 over x plus 4. In the numerator, the x plus 4 and x plus 4 will cancel, leaving us with 3. Now for the other one, we can distribute the negative 2. Negative 2 times x is negative 2x. Negative 2 times 4 is negative 8. In the denominator, we can distribute the 5. We can say 5 times x is 5x. 5 times 4 is plus 20. Here the x plus 4 and x plus 4 would cancel, leaving us with plus 2. We can combine like terms in the numerator. The negative 2x does not have any like terms, so it's going to say negative 2x. 3 minus 8 is negative 5. And the denominator, 5x, does not have any like terms, so it's just 5x. 20 plus 2 is plus 22. Is there any greatest common factors in the numerator besides 1 or negative 1? No. How about in the denominator? Nope. So, that there is as simplified as it gets. Any questions on any of this here? So we need to multiply top and bottom of this complex rational expression by something. What is one thing we know we'll need to multiply the top and bottom by? X plus 1. Do we need anything else? X, yes. Because the single x will work with the 1 over x on top and bottom. The x plus 1 will work with our other one, because it'll cause those to cancel. And again, we're going to multiply this whole expression by each of the numerators. So our x times x plus 1 times x. Well, the x times x is squared times x plus 1 over x plus 1 minus well, we'll get x times x plus 1 over x. Because our x times x plus 1 times 1 is just x times x plus 1. We'll do the same thing in the denominator. X times x plus 1 times x. Well, the x times x is x squared. And we still have our multiplication of x plus 1. Plus, when we multiply this with 1, we get x times x plus 1 all over x. Any questions on this here? Now, in the numerator, the x plus 1 and x plus 1 would cancel, leaving us with x squared. And the other part, the x and x would cancel, leaving us with minus our x plus 1. Now this here, we do need to be careful with distributing that negative because we will have to distribute the negative at a certain point. So it's good to leave the parentheses there for now. The denominator, x plus 1 and x plus 1 would cancel, leaving us with just x squared. Plus, the x will cancel, leaving us with x plus 1. Now at this point here, we can distribute that negative across the 2 in the numerator, which will give us negative x minus 1. Denominator, we can really just drop the parentheses because the plus doesn't really change anything. Now the question is will the numerator and denominator factor? Actually, no. We can check and make sure our b squared minus 4ac, square root of it. And for us here in the numerator, b is negative 1 squared minus 4. A is 1, C is negative 1. Negative 1 squared is 1 minus, well, negative 4 times 1 is negative 4. Times 1 is positive 4, which gives us 5. Can we take the square root of 5? No. So the numerator doesn't factor. Erase all this here. And the only difference between it and the denominator is that b and c are both positive, yes? Well, negative 1 or 1 squared is 1. Negative 4 times 1 is negative 4. Times 1 is still square root of negative 3. Again, doesn't simplify to a nice rational number. So the numerator and denominator do not factor. So this is it here. Any other questions on any of these here? You feel good about these here? We want to see one more? Yep. We're ready for the next one. This one here, the last one we're going to look at. I think there's one more. But we'll look at this one here. If we want to look at the last one, we can. Now, looking at this here, well, I'll give you all the choice. Do y'all want to look at this one here? Or this one here? Let's look at this one. Now, it'd be very tempting to want to multiply top and bottom by 2x plus 1 and x minus 4. We can see those for sure, yes? And then also, we'd want to multiply it by the 2x squared minus 7x minus 4. Will 2x squared minus 7x minus 4 factor? Let's see. There's not a number we can pull out of this here. And since the 4 is negative, our signs are opposite, yes? Positive and negative. Now, if we look at the factors of 2x squared, we'll have x and x, yes? And then we'll also need 2 and 1. Now, we're needing to figure out which one's going to have the 2 and which one's going to have the 1, yes? Are there any other factors that we could use as a hint? What's the first denominator in the numerator? 2x plus 1, yes? So if the 2 was with the plus, and we had a 1 with it, are we adding a new denominator factored in? No, it'd match up with the others, yes? X. Okay, so that works. 4 factors are 1 and 4 or 2 and 2. Let's try 1 and 4. So we can put the 1 with the 2x and 4 with the minus, yes? Does that match up with any of our other denominators? So whenever we approach these and one of them isn't factored, you need to factor it. So factoring the 2x squared minus 7x minus 4 did factor to 2x plus 1 times x minus 4, yes? So looking at all the denominators in the top and bottom of this fraction, x minus 4 appears how many times in each fraction? So it appears 3 times overall, yes? It appears once this middle fraction, yes? How many times does it appear there? Once. How many times does it appear in the next one? And in the bottom it appears? So how many times do I need to multiply it on top and bottom? Once. Anything else we need to multiply top and bottom by? What else is in the bottom of these fractions? We already did the x minus 4. What else do we need? Yeah. 2x plus 1. Because it does appear in the bottom of the fractions, yes? Because it appears twice in the numerator, but in each denominator in the numerator, it only appears 1 time, yes? In each one of those, it only appears once, so we only need it once. Because if it appears more than once in each of the fractions in the top and bottom, then we need it more than once. Does that make sense? It's a very funky sentence, but we think of each of the fractions on top and bottom individually. What do they need to cancel the denominator out? So we need to multiply this through. Okay? Now, are we starting to feel a little bit more comfortable with these here? Yes? I'm going to show you my shortcut way to do this. I'm going to write this in a little bit different color because what we're multiplying this by is 2x plus 1 times x minus 4, yes? This one's 2x plus 1 times x minus 4. Is what we're multiplying these top 3 by. And there's a reason I do this, because what we haven't been doing up to this point is something like this here, because the first one, the 2x plus 1 and 2x plus 1 will cancel out, leaving us with our 3 times x minus 4. The middle one, the x minus 4 and x minus 4 will cancel, leaving us with negative 3 times 2x plus 1 minus. Here the 2x plus 1 and 2x plus 1 will cancel. The x minus 4 and x minus 4 will cancel, leaving us with so essentially the steps that we've been doing in all the previous ones where we rewrite it out is just doing this. So we set it up so that they will cancel and then write it as in the canceled form. Yes. Because I forgot to write it. Thank you. Yes, if something like that happens, ask, because there's a good chance I just forgot to write it. there's too many times me and Miss Kendall will both agree we're so focused on the next step, we'll drop stuff like that all the time. But again, yeah, so we just need that x, yes. But doing it this here is a little bit nicer, especially if we're used to canceling and how that works, so we're not having to rewrite it. We did it on the previous step so that we can see this is how it's simplified. But once we get that understanding and have it, we don't necessarily need it every time. So the denominator, we'll have the 2x plus 1 times x minus 4. 2x plus 1 times x minus 4. And for the first one here, the x minus 4 and x minus 4 will cancel, leaving us with 3x plus 5 times 2x plus 1. Now, nothing simplifies with the 2. Now, there's two methods to go from here. One, we can rewrite it out as 2x plus 1 times x minus 4. Where did we get those two factors from? Weren't they this right here? So if we wanted to, I could rewrite this next to it 2 times 2x squared minus 7x minus 4. If we saw that there, then we could replace it. If not, now if you went on and wrote it as 2x squared minus 7x minus 4, that's fine. Leave it as that there. I'll finish this out real quick. We'll distribute the 3 here, 3x minus 12. Distribute the negative 3x, negative 6x squared minus 3x minus 27x. Here we're going to get 6x squared plus 3x plus 10x plus 5 plus, this is our 2x squared minus 7x minus 4. In the numerator, combining like terms, we'd have negative 6x squared. 3x and 3x cancel, leaving us with negative 27x minus 12. The denominator will have 6x squared plus 13x plus 5, and we distribute the 2. We'd get this here. Now I'm going to do some steps up top because we can factor out a negative 3, which would give us 2x squared plus 9x plus 4. The denominator, we'd get 10x squared minus x minus 3. And then if we factored the numerator, because we would have plus and plus, 2x and x, 1 and 4. The denominator would be two sets of parentheses, plus and minus. And we would have a positive 2x and 5x with the negative, 1 and 3. These would cancel, telling us that we have negative 3 times x plus 4 over 5x minus 3. If we got all the way to the end. So again, with that one there, if that was a little confusing, that's fine. I went twice as fast to the end. But just look back through it, it is the same thing as what we've been doing. And that's it. Y'all have a good rest of your day. If you do have questions, let me know. And if you're not